6-question sample set for the PARCC Math Middle School, and we'll start our test now. All right, so the first question says, Kelvin ran a 100-meter race at an average speed of v meters per second. He completed the race in 12.5 seconds. Part A, use the drop-down menus to complete the equation that can be used to find v. Now, for this problem, it would probably make a little more sense to make an equation out of this statement up here, and then that should better inform our drop-down options. So I'm going to pull up, all right, excellent. So when I take a look at this, I have a distance right here, and I have a speed, v for velocity I'm assuming, I'm going to call that a rate, and then I have a time. I should know off the top of my head an equation that relates distance, rate, and time. And it simply is distance is equal to rate times time. So let's fill in what I know about this equation, and then I'll take a look at my drop-down. So my distance is 100 meters. So let's just go ahead and do 100 meters right here. You gotta love trying to draw with a mouse. And that is going to be equal to my rate. Well, my rate is just going to be v, right? And I'm going to multiply it. I'm going to use the dot instead of an x so that I don't get confused about the variable x and the multiplication x. And then my time is just 12.5. Great. So with that, I am armed to now take a look at my drop-down menus. So I see here that I have a drop-down choice on one side of the equal sign. On my equation here, I only have the 100 by itself. So I am willing to bet 100 is going to be my best choice there. Then, let's see, what am I doing here? Well, I have v, and here's my v. I'm multiplying my v times 12.5. So I'm pretty sure one of these has to be 12.5, and one of them has to be times. Here's my 12.5, and lo and behold, there's my multiplication. So then I'm ready to move on to part B. What was Kelvin's average running speed in meters per second? Now, the trick on this one is you should know what the word per means. And the beautiful thing about this problem is it tells you how to do the problem. Per simply means divide. So we should do meters divided by second. Okay, so my meters would be 100. My seconds is 12.5. So there are a couple ways I could do this, and I realize most people would figure this out pretty quick, but if it doesn't come naturally, there's nothing wrong with putting the 100 inside the house and dividing it by 12.5. Now to do that, you would move the decimal place over 1, move the decimal place over 1. And so how many times does 125 go into 1,000? Now, most people at this point will say, well, 12.5 is half of 25, right? So 4 groups of 25 go into 100, so that means 8 groups go in here. But I'll go through this. So then, how many times does, well, it doesn't go into 100, so I just go ahead and guess 8. 8 times 125 does end up being 1,000, so there we have it. So I could do it the long way, or I could think about it and just realize that 12.5 is half of 25, and there are 4 groups of 25 and 100, so 4 times 2 is 8. Moving on to the next problem. It appears as though we have a ratio problem. So we have some research on bands, 3 bands. One band has brass players, has 123 brass players and 41 percussion players. Band 2 has 42 brass players and 14 percussion players. And band 3 has 150 and 50. Now, it goes on to say, put our answer in the box. The teacher realizes that there are blank brass instruments players per, and here's our per again, What does per mean? Per means divide. They want you to divide brass players by percussion players. So I'm going to be totally lame. And oh my goodness, there's a calculator here. So I can click the calculator, and let's just go ahead and divide it. 123 divided by 41, and that's 3. Well, let's see if that happens again with band 2. 42 divided by 14 is 3 again. Finally, 150 divided by 50 is equal to 3. I'm pretty sure at this point that this has to be 3. And it makes sense. So for every 3 brass players, I only have 1 percussion player. So moving on to part B. Mr. Ruiz has 210 students who are interested in joining a marching band. That is a lot of kids. He decides to have 80% of the band be made up of percussion and brass instruments. I guess the other 20% are baton twirlers. Use the unit rate you found in Part A to determine how many students should play brass instruments. So this one is a little tricky because I'm being asked to show or explain all of my steps. So I definitely feel more comfortable using mathematical language, and so that's what I'm going to do. I'm going to make sure I include my units so that anyone who's reading this, who is reasonably mathematically literate, can follow my thinking here. So first thing I'm thinking is, not all of the 210 students are playing instruments. Only 80% of them are. So the first thing I'm going to do is, I need to find out what 80% of 210 is. So since I am allowed to use a calculator, I'm just going to type in what I'm going to write in the calculator, and then I'm going to use the calculator. So I'm going to go 210, and I'm going to multiply it by 0.8, because that's how many people are going to actually be in the band playing instruments. And so now, after I've typed in my calculation, I'm going to use my calculator. Oh, it didn't look like I got the point. Times 0.8, there we go. And so I have 168 players in the band. Now, the next thing I need to do is, we need to use this unit rate. If I have 168 players in the band, I need to figure out how many of them are going to be brass players. Well, going back to my ratio, I have 3 brass players. I really want to say bass, and I don't even fish. But anyways, so I have 3 brass players for every 1 percussion player. So that is a unit rate. So that means that I'm going to use a fraction here. If I have 3, I'll do my explanation first. So I'm making a ratio, and I have my brass players over, and what I really want here is the total, because I know how many total players I have. I don't know how many percussion players, so I don't really want to say brass over percussion per se. What I really want, and what will be really useful, is brass over total. And so this is going to be equal to, no, I don't want that in the denominator. That's going to be equal to, well, how many players do I have that are brass? Do I know how many brass players I have? The answer is no, I don't. So I'm just going to put B for brass players. And then, do I know how many total players I have? Well, I have 168 players. All right. And so then I know that's going to be equal to 3 brass players. How many total players do I have up here? Well, if I have 3 brass players and 1 percussion player, that makes a total of 4 players. So I know that the number of brass players over 168 has to equal 3 brass players over 4 total players. So there are a couple ways you can do this. You could do cross multiplication, but what I would do is I would simply say that 4 times 42, actually let's just do it this way. Let's say let's say we have, I'm looking for a scale factor. What did I multiply 4 by to get 168? Well, for me to do that, I would have to work backwards. I'd have to do 168, where's my division bar, divided by 4, and that is going to equal 42. And this 42 is going to be my scale factor. Maybe I should not use it in parentheses. So that's going to be my scale factor. So now all I have to do is multiply the scale factor. It doesn't really like that R, does it? So now all I have to do is multiply my scale factor, 42, times my 3. And so let's go ahead and do that. We have 42 times 3. And so I have 126. Hello. 126 brass players. And so this way, at least I show every step that I do. Figure out what 8% or 80% of the total is. I figure out my ratio, and I told everyone what my ratio is, and then I went through and solved it and showed how I solved it. All right. Scientists are sending a rover to the moon. Their plan is to study a rectangular area of the moon by placing a grid over the map as shown. On the grid, 1 unit represents 1 kilometer. The rover will land at 3.5, comma 1. Maybe I should put a point there. So 3.5, comma 1. All right. And explore up to 3.5, comma 4. And then over to 2, comma 4. Plot these 3 points on the map. So we have those 3 points on the map. Now, the first thing I notice about this collection of points is it's creating a right triangle. And we have a base of 1, 2, 3, and we have a height of 1, 2, 3, 4, 5, 6. So that's something that I'm going to keep in mind. And these boxes, well, if each box is a half, this 3 is only 1.5, right? And so then these 6 boxes represents a change of 3. So we have 1.5 and 3. What are the coordinates of the 4th vertex of the rectangle that the science planned to explore? Well, to make a rectangle, I'm obviously going to have to put it right there, right? So that's going to be at 2, comma 1. So that's 2 over 1 up. Part C. What is the horizontal length of the rectangle? Enter your answer in the box. The horizontal length of the rectangle. Well, it would be from here to here, which is 1.5. My vertical length of the rectangle, just like we talked about, it is 6 boxes, but each box is worth a half a kilometer, so that's a total of 3 kilometers. Part D, find the area of the moon explored in square meters. Well, you know that area is equal to length times width. So that means that my area is going to equal 1.5 times 3, which means my area is going to equal, and just to make sure we don't make an error in the calculations, we'll use the calculator that's provided. We only need the 5-function calculator. We have 1.5 times 3 for a grand total of 4.5. And that's it. I'm going to show the next 3 problems on a separate video.